Good afternoon, ladies and gentlemen. I would like to welcome you at our episode 2 of our webinar series about precision farming and space data. Thank you for answering our opener question. I will end the poll now and share the results with you. We asked you for your opinion on which technology is the most interesting, or the application of technology is most interesting to you. You should see the poll right now, or if you don't see it, you can still click on the poll at the top menu or down menu, and you can see it. So the winner for this question is a variable fertilizing and anomaly detection and alert system. Those are the two possible use cases. So thank you for this, and we can move directly to the webinar. My name is Jan Labohi. I am CEO of World from Space and DynaCrop. And today we are here at the episode 2 of our Precision Agriculture with Space Data, Insights and Opportunities. In the last webinar last week, we were talking about the precision farming and precision agriculture trends for this year. It was more high-level debate, and you have an opportunity to check this episode on YouTube as well if you haven't catch it. And we're at the part 2, which means that there are still 2 more to go. You can register at our webpage, or if you're looking at our video, you can just carry on watching with them. Again, my name is Jan, and welcome to this webinar. Last time we were discussing more broadly, and this time we are welcoming you at the very specific topic. But first of all, let's just tell a bit about our company. We're a 5-year-old company based in Brno, Czech Republic. We're focusing on unlocking satellite data for agriculture and food value chain, opening the possibility to use the advantages and benefits for the companies that still are not experienced with this kind of technology. And we're working also with the European Space Agency, with the EU SPA on the national agriculture research projects, and with local farms and farmers. Also, I would like to thank to the eShape project, Horizon 2020 project, that gave us the opportunity to organize this kind of webinars and to share some of the findings with you. So let's look at the agenda today. We will have again very short introduction, high level, and then we will deep dive directly into the three use cases: pre-season fertilizing, variable rate seeding, and in-season fertilizing, or the application of parental regulators. And we will also capture some of the alert systems or anomaly detections, how satellite data can be used, and how, of course, DynaCrop can help you to make this much faster and much cheaper. So let's look on the higher scale from the beginning. So how actually we use satellite data in crop monitoring today, and what are the main benefits? So the main one, the biggest one, is the scale. As with all satellite data, larger area you need to monitor, the more important is to use satellites, because satellites give you the data frequently for all the area that you're monitoring and consistently. So you have the same kind of information, same kind of data for all of the fields that you are interested in. And it can be one field at the farm, it can be 100 fields at the farm, but it can be also thousands of fields that are insured by insurance company. The other possibility or advantage is the global nature of the data. So it means that if you need to compare fields that are in different areas in the world, you still have the same information, and you can build your products regardless of the geography. It brings a lot of information. It's valuable information. It can be used in different parts, and each plant or each crop has different use cases. So if we deep dive into it, you can also find very different ideas for different crops. And last but not least is, of course, the price, because satellite technology, even it sounds very expensive, is actually the cheapest and the less resource intensive way how to monitor at scale all of the agriculture activities. So this is the big scale. But I believe that you came for some specific examples, and we have 6 examples that we will talk about today. And this last one will be more a bridge to the next webinar that we will have on Thursday. So we will specifically look now at the variable rate fertilizing, seeding, application of crop protection. We will not today talk about variable rate irrigation, even though it's a very similar use case, only you're working with water instead of the other inputs. But we will also look at the crop growth assessment, how to check if everything is going okay. As we discussed last time at the first webinar, the variable rate technology is one of the key trends for this year. And it's a trend not because it's just emerging, but because we are in the adoption now. We are in the mainstreaming of the technology, and we can see really increased use of this technology throughout the whole Europe. We're looking mostly at the variable rate fertilizing, which is becoming the first technology that the farmers are adopting. But once they start using it, they're also moving to other possibilities like seeding or plant protection. The good thing is that the hardware is already there. The knowledge from the first adopters and the early adopters is already there. And this is becoming much more easier now for the farmers to jump on this bandwagon and start using variable rate technology. But still, it's not a major technology, so there is a huge space for experimenting, using the tests and working on the research, especially on combining the satellite data with the other possibilities of data from yield monitors or UAV or soil sampling and sensors and other technologies. To showcase you these technologies, we selected this one field, which we know very well because we're working with the owner of the field on a research project. It's about 30 hectares large, to give you the basic understanding if it's comparable to your situation or not. The plants that are typical in the crop rotation on this field are spring barley, corn, and winter rapeseed. The type of soil is a black soil or Chernozem, so it's a very fertile soil. And it's in the elevation of 300 to 325 meters above the sea level. It's in the Czech Republic, so the climate is temperate oceanic, nothing extreme. I would say a typical European field, even larger than the most fields, but otherwise pretty typical. So let's look at the first thing that comes in the season, and it's pre-season nitrogen fertilizing. So for this use case, when we are using the variable rate applications, this is usually before the seeding and planting is happening. So the idea is give the nutrition back to the field based on the consumption of the nutrition from the last year, and to create a big pool of the nutrition that the plant can use. So how we look at it with the satellite data. The first thing is to calculate the long-term yield potential from the past season. So we use the historical data about the field to create a map of places where we can expect higher and lower yield. Then we assess the field heterogeneity and zone stability, which means we look if the field is suitable for variable rate applications or not, and how much we can really trust the maps between the different years, if it's stable or unstable situation. Then we try to experiment with different strategies. It's based on the communication with the farmers that have different strategies, but also want to try what's the best for their field, because there is no just one best strategy for any field in the world. always needs to be tailored together with the person who has the local know-how, and it can be then connected with the satellite recommendation. And based on this, we create these prescription maps that are then used by the hardware. Let's look now at these individual steps. So yield potential assessment. As I said, it's the first step. And in this, we need to really understand the field's performance in the individual years with the individual crops. By doing this, we can find out if the field is heterogeneous, which means that there are places that needs different treatment. If the field would be same, the yield potential would be same, it would mean that the variable technology is not really suitable for this field and will not bring any benefits. More heterogeneous field means better prerequisite for variable technology. Also, the other thing we're looking for is the zone stability, because we need to understand if some parts of the field are better with specific crops, or if this is really the same throughout the years. If the zones are not changing, again, it's very good for variable applications. If the zones are changing, and with some crops you have good zones in some part of the field, but with other crops in different part of the field, again, the benefits of the variable rate applications are decreasing. If there are also other data available, for example, yield data, it's also very good to compare them. This is harder to do automatically, but it can be still done in the initial phase when we are setting up how the processing is done. And then we are looking at what is actually happening there, if there was some anomaly that we know from the past or not, just to make sure that the yield potential is done correctly. If yes, then we have a map like on the right that shows us the high yield zones. Those are indicated by the dark green color, up to the very low yield potential zones that are indicated by the red color. In this field, this is caused by a small ditch which is running through here, which means a lot of the nutrients are coming with the rain or with the water down to the ditch, which is then increasing the yield in these places. So we have this kind of a map. But to transfer it into the prescription map, we need some other information to be sure that we really make the map that can be used in a good way. So the first thing is it's really crop specific. So there needs to be some adjustments on the levels that are defining the zone borders. There are also different strategies. So for example, for this field, you can see that the farmer chooses a strategy to support most the middle zone. So the zone that has the average yield, and not to use more fertilizer in the bad zone, because it might not bring that much benefit, as well as in the high yield zone, because they usually have the high yield already. They're taking nutrients from other part of the field, so it might not be necessary to use it. But this is only one possible strategy. There are other possible strategies like supporting mostly the bad zones or supporting mostly the good zones. And it very much depends on the objective of the farmer, the specific crop, specific soil, and specific situation. So there is no one single recipe, but this can be always checked with other data and put together. When we have this map and the dosage, it can be then transferred with machinery and applied. But how to find out that it actually brings any benefit? That's the key question, and that's why we are working on the field trials as well, to test our maps on specific fields. And the idea behind is not to do the application completely based on the map, but to select specific testing stripes and apply different amounts in specific zones, while also having control zones when we don't do this, that are in the similar zones defined by the satellite data in the previous steps. So based on this, after the season, when the information from the harvesters come, we are able to evaluate which strategy was working the best at this individual field. And this strategy is usually then in the next year used for the whole field. Some of the farmers like to do more experiments and get the data all the time, but most of them wants to just set up the right routine, and then they don't really need to evaluate it every year when they know that the result is there. So this is the way how to actually control if the map that was provided with the dosage of fertilizing can work well or not. So this is it. What are actually the advantages? So we discussed that this is how to do the things, but why to do it? Yeah. The first benefit is that the farmer has this map which delineates the strong and weak part of the field. Usually the farmer knows like that some parts are worse than better, but it's very hard to make it quantifiable and to define the zones that needs different treatment. So in this way, the zones are already defined and can be used also for other activities, not just for fertilizing. The other advantage is that you really apply the fertilizer only based on the needs that the crop and the soil needs. So you can optimize it based on, again, your strategy. If you're focusing on regeneration of soil, it's a different strategy than if you're focusing on maximizing the yield. But always based on your strategy, this application can help you to do it, to achieve your goal in a better way. So with this, you are able, or the farmer in the end is able to increase yield by 10 to 20%. This is in the conditions of the Czech Republic. It can be better or worse in other geographies, always depending mostly on the variability of the field, the intra-variability. The other benefit, which can be there, but usually it's not at the same time, is the reduction of the consumption, which can be in Czech conditions 5 to 10%. As I was discussing last time, it can be, again, way more in different geographies. And again, it depends on the strategy of the farmer. If the main goal is to really reduce the environmental footprint of the farming and reducing the amount of inputs, or if the focus is on the yield. This technology, as I said, is the mostly spread. It's being used more and more, and it's the first step that usually farmers do when they start with the variable rate applications. The other part, which we can discuss now, is the seeding and planting. The idea of the technology behind is similar, which means the idea is to put only the right amount of the seed or the density of the planting to the field, so it can save you the input, but also have a positive effect on yield. But to solve this technically, we need to look at the certainly different parameters. The first step is the same as in the previous use case. It's assessing the long-term yield potential. But then we're working on combining this yield potential with the soil moisture maps, the availability of soil moisture. And then based on this, we're designing the prescription maps for seeding. So we've already covered the yield potential in the previous use case. So the first step would be the same, but usually we then look at the typical pattern of the water availability in the field, and also we check the effects of the drought in a field, because that's usually where you can see which part of the fields are vulnerable to drought and where the soil moisture is more stable, so it can support the crop also in the periods where there is not enough rain. So we create also the map of the water content, and we combine them into this soil moisture adjusted yield potential, which can be then transferred into the prescription map again. So the output is similar. We usually prefer 3 zones output because they are compatible with the most of the machinery. Some of the machinery can go up to 5 or 7 zones, but usually 3 is enough. And then again, for defining the population, the number of seeds or plantations per hectare, we need to look at the specific crop, because, for example, for corn and for wheat, it's the opposite way how you need to approach this idea, if you put more in a better zone or less in a better zone. And it's also hybrid specific. So it's not just the crop type which is necessary, but also the hybrid. Specific hybrids need specific density, and this needs to be taken account while creating this planting maps. So we usually create this map, also including the population, and then it's transferred to the seeding machine. And again, it's possible to do it as a field trial or a field test to check if the recommended method was bringing any additional benefits, or the flat rate approach would be enough. So what are, again, the advantages of variable rate seeding? The idea behind is to optimize the plant population, so really to have the right density of the plant that can create the higher value of the yield. It's also reducing risk of drought, logging and diseases, because with the plant density, you can, with a rightly set up plant density, you are able to actually decrease these risks of transmittable diseases. And if we look at the economics, the farmer can save 5 to 10% of the seed, while also improving the yield by 5 to 7%. So here we can see that the effect is a bit smaller than in fertilizing, and that's why also it's not usually the first step, variable seeding, but it's usually more the second step after the variable fertilizing is already being done on the farm. But here we have also made this economic calculation, which shows you that the return on investment can be about 100 to 120 euros per hectare, and which means that the equipment that is necessary for variable rate seeding can pay for itself in 1 or 2 years if the farm has at least 400 hectares where it can use this technology. So again, it needs some investment into buying the hardware, but usually this pays off quite quickly. We're not talking about tens of years, but really 1 or 2 years. Great, and we're getting into the another use case, which is in-season fertilizing, or the application of plant protection. So we've already seeded, the plant is growing, and the satellite can still help us with the application that are during the season. For this, it's always necessary to compare if the satellite is the right tool to do it, if maybe the sensors are already on the machinery, or the UAV will not bring more benefits. But regarding the optimal cost, the satellite is always the cheapest for this. So we're looking on how the crop is growing, if there are problematic areas, and if there is a necessity to adjust the crop growth with some regulators. This is an example of how we look at these anomalies. So that was one of these questions at the beginning. of how to monitor anomalies. Usually looking only on the one satellite image doesn't really show you where the anomalies are. So we are trying to use the combination of this yield potential to long-term patterns in a field with the actual state. And in compare, we can find out if there are some things that are not usual in this crop stage or not, because you cannot compare it in the whole season. It's necessary always to understand also in which stage the crop is. Based on this, we can see, for example, here on a left that this part of the field, there is currently some anomaly. It can be due to the pest or due to problems with the seeding machine, or it can be some disease. That's not possible to detect from satellite at the moment, but it's very good thing for field scouting, because then the farmer knows where to go, doesn't need to go throughout the whole field, but goes directly into this place and find out what's the problem. So that's how the anomaly can be detected. And if there is a necessity to provide the regulator, the plant growth regulator, or any other input, then we use some plant density parameters together again with the phenological data and other kind of data. And we are able to create also the prescription maps for the plant growth regulators in order not to give too much or too less to the spots. Great. So we've covered all of these use cases that we have here. And this idea is that we like to help companies doing this. That's why we started DynaCrop Space, which is, we call it the white label ecosystem for digital farming. So it's a system that automatically analyzes satellite data and create maps and exports them to your software or to any other product that you're selling directly to the farmers. We work anywhere in the world, and we are able always to specify the product based on your needs and make the price also based on that. So our approach is to create this kind of maps together with you to set up the specific use cases, look at the individual plants and crops, and define the variable rate maps for fertilizing, seeding, or other applications. Next week, we will also talk about how to use these maps for soil sampling and field scouting. So how to optimize the soil sampling network, that it's giving you more information from the soil sampling, and you can use it also for variable application of other elements, not just nitrogen. With variable rate technology, the other important thing is also timing. It's not just only about having a fitting map, but also doing the application at the right time, which is a problem that we try to address with the phenology detection and the crop growth staging, so the farmer can understand which growth stage is at each field, what is the expectation, and then plan the application accordingly. And the last problem we're trying to tackle is the weather problem with the satellite data, which means that we're combining optical and radar data. So even if there is a cloudy weather, we're able to actually provide the information about the field and the crop growth and create these prescription maps, even if there is no optical image available. We call this system Leica because it's providing the leaf area index or light at every 2 to 3 days in the European context, based on the different satellite data fusion. And that's it from my side from today. I'm opening the floor for questions. We were discussing mostly on how to use the satellite imagery for providing prescription maps for fertilizing, seeding and the application of plant protection. And if you have any question, you can write directly into the Q&A session. The first question is, can we predict the crop using NDVI? So this, if I understand it correctly, is we can detect what kind of crop is growing on the field. Only NDVI is usually not enough. Even for some of the crops, it can be enough. For example, for corn, due to the late time when and very fast growth in some stages. But usually you need to combine multiple vegetation indices like NDVI that come both from multispectral and radar, and then you are able to say what kind of crop is there. Great. Another question: how do you measure water content? Is this an information from satellites? Yes. So we're looking at the soil moisture information, which are based on a fusion of radar and multispectral satellites. So the information gives you, the information we give you is the relative amount of water in the top level of the soil. So you cannot get the information from a satellite that will tell you the amount of water in the root zone. This needs to be modeled using the satellite as one of the inputs, but also some other data. But not usually, the general idea is that it gives you the information about the soil moisture and the canopy moisture. So how much water is actually in the plant itself, if it's drying out or if it's fine. So yes, this is how we do it. And we can move to another question. Which bands do you use for yield potential calculation? So this we will not tell you which bands we use. We have an algorithm which is set up there, but our system enables you to combine the bands that you want also, or bands, the multiple vegetation indices. We have around 19 parameters, which we monitor from satellite, and each of them can be combined. But for the yield potential, we're using not the standard NDVI, but other vegetation indices that you can find in our system. And how do you measure soil moisture content? Yes, this was already answered, but I can add also that we are combining this information with the data from soil moisture sensors from our research partners. So we measure the soil moisture through electric conductivity, and then we compare the information from the soil moisture sensors with the information from a satellite. Then we have another question: how you deal with mixed pixels and field edges? Are you correcting for the influence of a neighboring field, road, or water body? That's a very good question, and the mixed pixels are a big headache. Usually, the biggest problem is when you have, for example, the 3 alleys on the size of the field, and we are solving this with some geospatial algorithms. Usually, I don't want to disclose exactly how we do it, but we solve this problem, and it's working well on larger fields. It doesn't work well in the very small fields. There, the mixed pixels are a problem, and the only solution is to work with a better resolution of the data. So preferably with the data from Planet, which we are currently integrating into the system. So another question is, what is the difference water content and NDWI? Yes, each indice for water content derived from the multispectral and radar data has significantly different nature and can be really used for specific cases, not for all cases. So for some of the use cases, the NDWI is good. It's mostly for standing water detection, for example, but for understanding the canopy content, the water in canopy, it's not the optimal, and then it's, for example, better to use the NDMI or other water-related indices that we have in the system. We have another question. Growth stages data, they are not available now in the platform, but we're working on it, and we will be happy to work together if you are interested. This year we've already conducted experiments on corn, and this year we'll also do some corn experiments with the growth stages, but also we would like to work with the winter wheat and canola for the next season, so we can discuss later the possibility to do this together. Another question is, what is the best way for field crop best practice from drones or satellite imagery? Okay, so if I understand this question correctly, it's if it's better to use drones or satellite imagery for crop monitoring. And the answer is that each use case has a different technology that is more suitable. The satellite data are mostly suitable for the applications where there is still no plant. So it's for pre-season fertilizing or for seeding or planting. Once there is the crop and you really need to understand the needs and the stage of individual crops, then it's better to use the on-machinery sensors or drones, something which has better resolution and can really see the state of the plant and its nutrition, and can give the application of, for example, plant protection or fertilizing during the season, really can give the right amount of the fertilizer to the stage of the crop and the situation. So this is not something that can be said that drones or satellites are better. Each technology is better for some part of the process. Another question, can we have access to the recording? Yes, of course, it will be available on YouTube, and we will send you a link once it will be uploaded there. So you will be able to see the whole webinar series, or also check the previous one that was regarding the regenerative agriculture. If there is still some other question, you can ask. Otherwise, I will invite you into this session when we will discuss the soil monitoring and how we do it. Especially, I would like to welcome the people who were asking the question regarding the soil moisture, because this will be a part of this session. So that's it for today. My name is Jan Labohi. We will be very happy to discuss with you what you do, how you do it, and if there is any way how we can do it together. You can book a meeting directly here, or just send me a message on LinkedIn, email, or phone, whichever you prefer. And as a last thing, I will end the poll and show you the results. So 81% of the people thinks that satellites are the crucial technology for precision farming. That's good that after this webinar about satellites and precision farming, you think this, otherwise you wouldn't attend. So thank you for your time. I wish you a productive week, and I'm looking forward to meeting you on Thursday at our next webinar. If not, there are still some questions, so I will look at this. Yes, so for collaboration, feel free to send us an email. Also, if you are an intern and you're looking for an opportunity to do your internship, we will be very happy to answer you. And or Philip, I think it would be the best to get in touch together and discuss this specific question together. So thank you. Have a nice day and goodbye.